And put this under, let's call this linear equations. Linear equations. If you had to guess, if you had to guess what linear equations mean, taking apart the label there, what do you suppose it means? Anybody? Alex says, yes, he said it exactly as I would. Equations that are lines. And here is an example of one. Let's just say you picked up a job working at a restaurant, and in that job, for your job, here was how you were going to get paid. For that job, you made $2 an hour. Plus, well, that's not very much. $2 an hour plus, just for showing up every day, you would get $3 just to show up. Now, if you wanted to write an equation for that, everybody know what that equation would look like. Now, think about it. And this is, people have a hard time with this, okay? When you don't know what the equation is, put some examples in. Here, let's make a chart with some examples. This is the number of hours you work, and this is how much your pay is. Let's put some examples in there, okay? If you show up, but don't work any hours, how much will you be paid? $3. If you show up for 2 hours, how much will you be paid? $7. Now, for those of you that say you can't write an equation, okay, you have already done it, you just didn't write it down. In other words, think what process, in order to get $7, what did you do to get $7? Multiplied by what? By what?
By 2.
Okay, so you took the hours, correct? Multiplied it by 2, but that didn't give you 7 because you then had to add the $3 to it. Here is your equation. To find out how much dollars you make, whatever the hours is, you multiply by 2 and then add 3 to. If you work 6 hours, 2 times 6 is 12, plus 3 is, you made $15. Now the reason this is a linear equation is because there is no one specific answer to it because it depends on how many hours you work. There's multiple answers to this based on how long you work. So the way we show that is we make a line graph of it. Or we just graph the line. Okay, where in math, a lot of times for this first number, the input number, we've talked about this before, we call this the x number, the number you input, and the number you get out is the y number. So if I'm graphing this, here's what it looks like. These, by the way, are my coordinates. These are my points. We've graphed points before. 0, 3. 0 hours, x is my amount of time, hours. If I work 0 hours, I get paid $3. If I work 2 hours, here's 2 hours, I get 1, 2, 3, 4, 5, 6, 7 hours, or $7. If I work 6 hours, 3, 4, 5, 6 hours, I get paid $15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This line, if I connect my dots, which will make a line, that line right there represents all the different combinations of how many hours I work and how much I would make. In other words, if I looked here at 4 hours, if I work 4 hours, I'm going to make 1, 2, 3, 4, 5, 6, 7, what is it? 11 hours? Wait, I'm sorry, this was 3, 4 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This would cross at 4, 11 because I would make $11. This is a linear equation because when I graph it, I get that line. Now, here comes the whole exciting part about this. Okay, the first thing you have to recognize is we have what we call the standard form, or the way we write a linear equation like the generic form. It is this, and you'll see this a million times in the rest of your life. Y equals mx plus b. Write that down. Y equals mx plus b. Got that written down? As a matter of fact, that is worth so much weight, I am going to do it here. Y equals mx plus b. When you have this equation, it is called this. It is called the slope-intercept form. I guess let's just call the book this. Slope-intercept equation for a line of a line. Write that down, and then we're going to talk here. And I wish we could go to the computer lab today, but we can't. So this will be good. Okay, what that means is this. This is called the slope-intercept form or equation because it is written so that you can find the slope of the line and what we call the y-intercept of the line. This number right here, the letter M is the slope of the line. We've done slope, have we not? Draw triangles coming up and over?
Yeah.
Okay. The letter B is what we call the y-intercept. If you had to guess what intercept means, what does y-intercept mean? It is where the line crosses the y-axis. Where a line crosses the y-axis, not the x, the y-axis. And the beauty of this, ladies and gentlemen, and kids of all ages, is this. I will show you as soon as you're done writing that down. Y equals mx plus b. The beauty of this is this. If you go back, I'm pretty sure in almost every lesson, they ask you to graph a line. Let me find here. I'll find one. Work with me here. I'll find an example here. Here. If you look back, you don't have to. 352, problem number 13 says graph y equals 4x plus 1. How did you graph that line? Somebody help me out, unless you all cheated and did graph it. How did you graph that line, Ryan?
What do you mean, that one?
If the direction said to use that equation and graph the line, how did you graph it?
I would make up a number for that.
Okay, what you were told to do is you were supposed to make a table, correct? Which would be this, of x and y values. How did you know where x came from? Where'd you get your x numbers?
Make them up.
You make them up yourself, and usually, hopefully you put 0. You put a positive 2 maybe and a negative 2. Let's just do that. And then you had to stick these numbers in here, right? 4 times 0 is, plus 1 is, 2 times 4 is, plus 1 is 9. Negative 2 times 4 is negative 8 plus 1 is negative 7. And then you come over here and you would plot those points 0, 1, 2, 9, and negative 2, negative 7. You would come down here and you'd get your line, correct? Everybody's good with that? Well, if the equation is in slope y-intercept form, you don't have to do hardly any of that work at all. Because you are given the two things you need to know to graph that line. You are given the slope, which is this, and you are given where it crosses the y-axis, which is that, the y-intercept. So it looks like this. Step number 1, when you graph in slope-intercept form is, step number 1, I'll write this down here, okay, plot the y-intercept on the y-axis. In other words, this last number that sits out there without the x at positive 1, that's where the line is going to cross the y-axis. So automatically I just look at that and go, oh, it's going to cross the y-axis here at positive 1, which it did if you look at our actual graph. And then the second thing you do is use the slope to make more coordinates or dots or whatever you want to call it. Which means this, children. What is the slope of this line?
4.
Huh?
4.
4. And we usually call slope in fraction form, so we make it 4 over 1. What that means is from this point, I can just go, slope means how far up over how far over. I can just go up 4, 1, 2, 3, 4, and over 1, and put a point. Because this line has to have that slope from that point. Or I could go down 4 and over 1. And then I could go up 4 again from this point and over 1 again and plot as many points as I want. But your line is going to look just like this, which is the same line that this one was when we had to do this table. Now it took us a little longer than usual because I had to explain each step, but you'll see how fast this is once we do this. Let's write that down and then we'll talk about one. Ready? So if you have something like this, y equals 3/4 x plus 4. Watch how quickly you can graph a line. We'll start with your graph there. First thing I do is put a dot or a point where, a coordinate where. Where does it cross the y-axis? At, help me out here, 4. This is the y-intercept. So here at 1, 2, 3, 4, I put a point. What is the slope of the line from that point? 3/4, which means it goes up 3 over 4. So from this point, well, you can go down 3, it doesn't matter. Up 1, 2, 3, over 1, 2, 3, 4. Now here we have to stop for just a second and talk about this. Unfortunately, children, I can go over 4 in 2 different directions. How do I know which one it is? Cameron? Well, it has to be the one that gives you a positive slope. And a positive slope has to go uphill. So which one of these, if I connect this one this way or this one this way, which one gives me the positive slope? Has to be this one. So bam, I draw my line between those 2 points, and that's the graph of that line. If you had to sit and put numbers in for x with the fraction 3/4, it might get a little ugly for you. But I can tell you're excited about that, so let's move on. How about y equals negative 1/2 x minus 6? Here's how fast that you can graph a line. Crosses the y-axis at negative 6, 1, 2, 3, 4, 5, 6. And from this point, don't go back to the origin when you do your slope. You got to go from that point right there. It goes up 1 over 2. Up 1 over 2. It has to be negative slope, so I have to go this direction, and there my line is graphed. You don't have to sit there and make a table. You don't have to do any of that sort of stuff. They have one here. Oh, look at this. Yeah, we have to look at it. One more. Actually, I'll let you sketch the graph of this one on your own. How about this? Y equals negative 3/5 x plus 3. Sketch me the graph of that. Y equals negative 3/5 x plus 3. Gotta do is follow the simple rules. Y-intercept and slope. And see what you got. You should be way done by now. No need to draw tables or go into that stuff. And point to me your graph when you're done. Show me where your graph is there. And when you draw a graph, your lines should go all the way through. Don't just stop at those endpoints. If you draw a line, it should go all the way through your graph and have everything to the time of it. Make sure your graph should be a negative slope, so it should go downhill. If it's going uphill, then you went the wrong way. A lot of you are going uphill, not downhill. Should go downhill, so down, downhill. The little skier that's going uphill. It's going uphill. If it's negative slope, people, the line has to go this way. Positive slope goes that way, negative slope goes that way. And here's what it should look like. In 3 easy steps or less. Crosses your y-axis at 3, so 1, 2, 3, put a dot. From that dot, you go up 3 over 5. Up 1, 2, 3. Now you have to decide, are you going over 5 that way or over 5 this way? The line has to go downhill, so your 5 has to go over this way. 1, 2, 3, 4, 5. And there's your 2 dots. You connect them, and that's how your little linear equation should look.
I got this sticky note from Mrs. Swenson for you to have. She just go put it on your desk.
I'll take it. Is it about her son?
No.
Got that? Now, open your book to page 384. Because not only do you need to build a graph given this equation, but you got to be able to look at a line and say what the equation of that line would be. Thanks, Davis.
Can you go down?
You certainly could. If you go down from here, 3, maybe 1, 2, 3, you just have to realize you're going to have to go 5 over this way. 1, 2, 3, 4, 5. You can go up or down, left or right, but you got to make sure it fits into whether it's positive or negative slope. Take a look at page 384. They give you 2 examples of lines there. Line letter A. Look at line A. Do you see the blue line, line A? You are asked to give the equation of line A, and you have to remember, here's what you're starting with. Y equals mx plus b. You just need to find 2 things. You need to find out where that line crosses the y-axis. If you're looking at line A in your book, where does that line cross the y-axis? Kayleen? Line A crosses that 1? Line A crosses that -2. So you can automatically put -2 in for B. Now you just have to fill in what's in front of the x with whatever the slope of that line is. So you have to look at the triangle. They already made it for you. How high is that triangle over how wide is it? How high is the triangle it makes over how wide is it? What do we got there? Grace, what do you think? How tall is the triangle? Any of the triangles they give you for line A. How tall is it? Over? That triangle is too wide or it's too high and how wide? Line A. I don't get 2 over 2. You get 2 over 2? Ryan?
2 over 1.
It's 2 over 1. And that's only 1 unit wide. Is it positive or negative slope?
Positive.
Positive. So there's your equation. Y equals 2x minus 2. You don't have to leave it as a fraction. How about line B? Y equals mx plus b. Line B. Where does line B cross the y-axis? Alex?
Positive 1.
At positive 1. And then you just have to give what is its slope. How high is that triangle over how wide is that triangle? Caleb? 1 over 2. Is it positive or negative? Going uphill? Yep. So there is your equation of that line. So you kind of got that? What else did we have here? Let me look here. Got it. On up to page 386. Ready?